top view of a line 75 mm long measures 50 mm. The NP is 30 mm in front of VP and 15 mm above HP. The NQ is 15 mm in front of VP and above HP. Draw the projections of the line and find its inclination with HP and VP. So here, when you look from the front view, the NP is 15 mm above HP. So you can see the distance above HP, which is 15 mm. When it looks from the front view, the image will going to fall on the vertical plane. So the distance of 15 mm can be seen here, and you mark this point as P dash. And then NQ and 30 mm in front of VP. When you look from the front top view, you can see the distance 30 mm in front of VP. That image will going to fall on HP, and you mark this point as small p. And then he says the NQ is 15 mm in front of VP. So in front of VP can be seen in the horizontal plane. So from here you measure 15 mm and draw a horizontal dash dot line, which is going to be the locus of Q in the top view. So we have in front of VP. But we know that the top view and also true length is given. So measure 50 mm, you cut an arc on this, so you're going to get this small PQ. And here take 75 mm, cut an arc on this, so you're going to get the true length in the horizontal plane. So once you know that this is the true length in the horizontal plane, you know that small capital P is here. So from here also this line will be 15 mm. And then with P as center, taking the radius, because we know the top view, you draw a vertical projector from here and to the above HP perpendicular to the XY line, perpendicular to the horizontal plane. With P as center, taking the radius of PQ1, you rotate it such that it will going to cut this end projector here. So you mark this point as capital PQ. Now we got this line. So when you look from the front view, we can see that P dash Q dash is the one which you're going to get. So when you are rotating like this, what happens? When you look from the front view, we can see. So when you are projecting a line from here, so that means that line is what? That is this line which is projected. And when you are rotating from P to Q1, when you are rotating its space, so that it will going to cut this end projector line. But here, when you look from the front view, that image will going to be here. So on the vertical plane with P dash as center, taking the radius of P dash Q1 dash, you rotate it so that this will going to cut on this end projector line. So that you are going to get this Q dash, small q dash. Then draw a horizontal dash dot line, which will going to be the locus of Q in the front view. So now we want to find out the true length in the vertical plane. So to find out the true length in vertical plane, with capital P as center, taking the radius of capital PQ, you make that capital Q is also in front of VP by 30 mm. So that means you are rotating that capital PQ by such that Q2 should also be in front of VP by 30 mm. Once both P and Q2 are in front of VP by 30 mm, then obviously you will going to get the true length, that is it is parallel to VP. So you are going to get the true length in the vertical plane. So that P dash Q dash will going to be obtained. So this is how. So what you are doing is when you are rotating like this, so what happens, that image will going to be rotated in the top view, that is in the horizontal plane. So you make P as center, taking the radius of PQ, you are rotating, make it PQ2 is in front of VP by 30 mm. So once you do that, when you are projecting that, it is going to cut on the locus of Q in the front view. So you mark that point as Q2 dash. Since P dash P capital PQ2 is the line which is parallel to VP, so you are getting the true length here, and you mark this as capital Q2 also, and you mark this point as Q2 dash. Then join P dash Q2 dash also, and also PQ. Now this is how we can analyze it in 3 dimension. Now we will going to solve it by step. So to do that, so first we will going to consider the true length in the horizontal plane, means that line is parallel to HP. So that means both P and capital Q1 are both above HP by 15 mm. So you are going to get the true length in the horizontal plane. And now we know the top view point is also given. So since you know the top view, the front view point of that Q should lie on this line. With P as center, taking the radius of PQ1, you rotate such that in space, such that it will going to cut this vertical projector here. So you mark that point as Q. So when you are doing so, that the image, so what happens in the vertical plane? So vertical plane means we have to see from the front view. So when you look from the front view, both P dash and Q1 dash is above HP by 15 mm. With P dash as center, taking the radius of Q1 dash, you rotate it such that this will going to cut on the end projector line of the front view, so that you will going to get this point Q dash. Then join P dash Q dash with a dark line, and then you identify the locus of Q in the front view. So that is what we have shown here in the orthographic view. So that means we have the top view and also the true length in the top view. Then you draw a vertical projector from Q to the front view, such that the front view point of Q dash should lie on this end projector. So now you take the top view true length. You make that, since it is the top view true length, it should be parallel to XY line in the front view. So P dash is above HP by 15 mm and Q1 dash should also be above HP by 15 mm. So draw a vertical projector from to the locus of Q in the front view with P dash as center, taking the radius of P dash Q1 dash. You rotate it such that it will going to cut on the end projector line of top view point of Q. So we're going to get this point as Q dash, and then join P dash Q dash. Then draw a horizontal dash dot projector, which will going to be the locus of Q, and you mark this as the locus of Q. So now we are going to consider then the top view now. So we want to find out the true length in the front view. So the line which is in space, which is capital PQ, you may with P as center, taking the radius of capital PQ, you rotate such that both capital P and Q2 are in front of VP by 30 mm. So now the line is parallel to VP. Once the line is parallel to VP, so what happens? You are going to get the true length in the vertical plane. So when you project that, you will going to cut on the locus of Q in the front view. So you join and you mark this point as Q2 dash. Then join P dash Q2 dash, which will going to be the true length. But when you are rotating in space, what happens? When you look from the top view, that image will going to fall on HP. So with small p as center, taking the radius of PQ, you are rotating, make it parallel. Both small p and Q2, small Q2 will be in front of EP by 30 mm. So now you draw a projector from here to the front view, so that it will going to cut the locus of U in the front view, and mark this point as P dash Q2 dash. So this is what we have seen in the orthographic view also. That means you are rotating the top view point PQ, make it parallel, and when it is projected to the front view, so you are going to get the true length, and that is why reason why you mark this as capital P and capital Q. So this is how we will be able to solve this problem in the stepwise. Now we will going to consider to solve the problem by using the XY line and mark XY and VP and HP. You know that the NP is 15 mm above HP and 30 mm in front of VP. So from XY line, you measure a distance of 15 mm above XY line and draw a horizontal line. And similarly, from XY line, you measure 30 mm, which is in front of VP, which is below XY line, and you draw a horizontal line. Consider any point. From here, you draw a vertical projector, which should be a thin line, and so that it will going to cut this point here, which is P dash, and which is small p, which is here. And you mark this as capital P in bracket and capital P in bracket here. And also 15 mm in front of VP. In front of VP can be seen below XY line. So from XY line, you measure 15 mm and draw a horizontal dash dot thin line. So, and that you will going to mark it as the locus of Q in the top view. Then by using the compass, you measure a distance of 50 mm, and with P as center, cut an arc on the locus of Q in the top view, and you mark this point as small q, and draw a join P and Q with a dark line. And similarly, by using the compass, you measure a distance of 75 mm with P as center, cut an arc on the locus of Q in the top view, and you mark this point as small q1, and join P and Q1 with a little bit thicker than the XY line, and you mark this point as capital Q in bracket. That is because he has given it as the true length in the true length line. Since we know the top view point, the front view point of Q dash should lie on this end projector. So from Q, you draw a vertical projector. It should be a thin line to the front view, and you consider the top view true length. So since it is the top view true length, that is both P dash and Q1 dash should be above HP by 15 mm. So from Q1, you draw a vertical projector, which should be a thin line, such that P dash Q1 dash should be above HP by 15 mm. With P dash as center, then you take measure a radius of P dash Q1 dash by using compass, with draw an arc such that it will going to cut the end projector which is drawn from Q. So you are going to mark this point as Q dash, then join P dash Q dash with a dark line. Once you get this Q dash, Through Q dash, you draw a horizontal dash dot line, which should be a thin line, and you mark this as the locus of Q. Now we need to find out the true length in the vertical plane. You take the line which is inclined to VP. So the line which is inclined to VP is small pq. By using the compass with P as center, taking the radius of small pq, draw an arc such that both P and Q2 are in front of EP by 30 mm. So then from Q2, you draw a vertical projector such that it will going to cut the locus of Q in the front view, and you mark this point as Q2 dash, then join P dash Q2 dash with little bit thicker than the XY line. Since this line is, since PQ2 is the line which is parallel to XY line in the top view, obviously its corresponding front view will be in true line. So you mark that as capital Q in bracket. Then this will going to be, denote this angle which is theta, that is the true inclination with respect to HP, and you denote this as the true inclination with respect to VP. Then you show the dimensions of 50, 75, 15, 30 and 15, and then by using the protractor with P dash as center with respect to the horizontal line, you measure the true inclination line with which is theta, which is 48.19 degree when you are doing it in computer. When you are doing it in manual, it will be 48 degrees. Similarly, with P as center, measure an angle of with respect to VP, which is the true inclination with respect to VP, which is 5, and you mark this as 11.54 degree when you are doing it in computer. When you are doing it in manual, it will be 12 degrees. So this is how we will be able to solve this problem in the